Hey, Future AI here, back with another video. Today, we're talking about one of the most futuristic projects Google has ever revealed. It's called Project Suncatcher, and it could completely change how artificial intelligence is powered. Imagine a network of satellites orbiting the Earth, running AI models directly in space, powered entirely by the sun. That's the vision Google's research team has presented: a scalable, space-based AI infrastructure that uses endless solar energy instead of relying on data centers here on Earth. So how does it work? Google's engineers describe Project Suncatcher as a constellation of small satellites, each equipped with powerful AI chips like Google's TPUs. These satellites would orbit roughly 650 kilometers above the Earth and communicate with each other through high-speed laser links. Together, they would form a sort of AI cloud in orbit, capable of processing huge amounts of data day and night without worrying about power shortages or cooling systems. It sounds like science fiction, but this concept is already being tested in simulation and small-scale prototypes. Why would Google want to do this? Because today's AI models consume an incredible amount of energy. Training large language models or image generators requires massive data centers that burn through megawatts of power. Cooling alone takes up to 40% of total energy use. In space, solar energy is constant and about 8 times more effective than on Earth. Without an atmosphere blocking sunlight, these orbital servers could run 24 hours a day using pure, clean energy. Google says its next-generation TPU chips already show promising results in radiation tests, which is one of the biggest challenges in orbit. Temperatures swing from freezing to boiling, and cosmic radiation can damage electronics. But early experiments showed that Google's hardware can survive far better than expected. Still, the biggest limitation right now is cost. Launching hardware into orbit isn't cheap. For Suncatcher to compete economically with normal data centers, launch costs would have to fall below $200 per kilogram. That could happen within the next decade, thanks to reusable rockets and new launch providers. The concept also relies on extremely fast data transfer. Laser communication between satellites could reach several terabits per second. Google has already demonstrated 800 gigabits per second in lab tests, enough to synchronize AI workloads across multiple satellites almost in real time. But the real bottleneck is the link between space and Earth. Even if satellites talk to each other seamlessly, all that data must eventually reach the ground. Google envisions a network of optical ground stations capable of downloading petabytes of information from orbit using laser beams. Environmental impact is another big motivation. AI data centers on Earth require enormous amounts of water for cooling and consume up to 5% of global electricity. A system like Suncatcher could avoid those costs and emissions entirely. It wouldn't need water, land, or cooling systems, just solar energy. The downside is, of course, rocket emissions. Launching hundreds of satellites still adds CO2 and other pollutants to the atmosphere, so balancing sustainability will be critical. Google isn't doing this alone. The company is working with Planet Labs, known for its satellite imaging fleets. Their joint plan is to launch the first prototype as soon as 2027, using 2 small satellites equipped with test TPUs. These early missions will study how well AI chips perform under radiation and whether laser communication can handle large-scale machine learning data. If it works, the long-term goal is to build clusters of dozens or even hundreds of satellites, forming kilometer-wide AI arrays that orbit the Earth like digital suns. If successful, Project Suncatcher could give Google a massive strategic advantage. Today, AI progress is limited by access to GPUs and electricity. But if compute power moves to orbit, those limits disappear. Google could scale AI far beyond Earth's infrastructure, free from power grids or local regulations. That might sound exciting, or a little scary. After all, an AI system running beyond human reach raises serious questions about control, safety, and transparency. Who oversees a satellite that can think? Who's responsible if something goes wrong up there? Critics have already warned that launching AI hardware into orbit increases the risk of space debris and collisions. Google says its satellites will be designed to safely deorbit at the end of their lifespan, but a large-scale network still adds complexity to an already crowded sky. There's also the issue of cost. Even if launch prices fall, maintaining hundreds of satellites and ensuring continuous connectivity would be a huge technical challenge. Still, Project Suncatcher might represent the next logical step for AI infrastructure. Computing power has always evolved alongside energy. Steam engines, electricity, the cloud, now sunlight in space. If this works, it could open a new era where intelligence itself is powered directly by our star. Instead of data centers heating up cities, we'd have solar-driven AIs orbiting silently above the planet, learning, analyzing, and creating in the endless daylight of space. It's hard not to be fascinated by that image. AI leaving the Earth to grow in the light of the sun. Whether it happens in 5 years or 15, Google's vision pushes the boundaries of what we consider possible. It's not just about efficiency, it's about ambition. A reminder that technology doesn't have to be limited by geography or infrastructure. It can reach beyond the planet that created it. And that's it for today's video. Pretty wild to think AI might soon live in space, right? Thanks for watching. If you enjoyed this look into Google's cosmic AI vision, make sure to leave a like, subscribe for more future AI content, and share your thoughts below. Would you trust an AI that operates from space? I'll see you in the next one.